now we are moving further through our program, and let me invite Executive Director of Sberbank, Dmitry Bugaychenko. Dmitry has close touch with implementation of current next-based action solutions, and today on evolutionary topic. To history of recommendation system evolution from early findings in 1990s till now. We will find out about Netflix price and learning to rank. We will touch very sensitive topics of bias and privacy. So, Dmitry, let me welcome you. The stage is yours.
Hello everyone, thank you for inviting me to the AI journey, and I hope you will enjoy my talk. My name is Dmitry Bugaychenko, I'm representing the... Today we are going to talk a bit about the history of recommender systems. I've been working with recommender systems for almost 10 years for now, and I think that recommender systems are on the top of the ML algorithms chains, because then you are working with a recommender system. You need to work with the content. It could be text, or it could be video or an image, and you need to use the appropriate methods. You need to work with logs in order to mine patterns of users' behavior. And you also need to work with technologies, because in the recommender system, it's not enough just to make a model or train a model. You need to work on a model in a real time, in a production environment with high availability requirements and very strict requirements for latency. It's a very interesting area, and today we're going to discuss how it evolved. It starts pretty long ago, 30 digital bookshelves, and this paper was rejected from the conference Interact about human-machine interactions. And the interesting fact is not that the paper was rejected, but in the motivation reviewers used to reject the paper. Looking at these motivations from the point of view the years 2020, it really feels like someone tried to get back to the past and prevent recommender systems from happening, because the motivation is now the recommender systems, they actually not just helping users to make the decision. In many cases, they push users, and it's true for consumer behavior in online shops or in different content platforms, and it's also often true even in areas like politics. Then using a social media and the recommender system there, we can create a filter bubble for someone to force him to believe something. And of course, that didn't help, and recommender system became appearing a few years later. And initially, it was a very user-centric view on the recommender system. The main goal for recommender system was to help user to find content in the places that there are a lot of choices. And the interesting thing is that first recommender systems were actually built by scientists for scientists to help find scientific articles. But soon that this approach works not only for scientific articles, but also for many other contents, and a lot of different recommending engines start growing and growing and growing in industry. And then one of the key points in the recommender system history is, of course, the Netflix price. At the year 2009, $1 million was given to the team who showed the algorithms improving the performance of the Netflix recommender for 10%. Of course, it was not yet 10% improvement in production. It was competition environment, and it was long ago, before the Kaggle and all the rest competitions. It was one of the first famous machine learning competitions. Is that giving this $1 million, it's a pretty huge sum to the team of scientists. Netflix showed that actually, even at that time, the profit produced by the recommender system for Netflix was measured in hundreds of millions of dollars, and giving $1 million for and it means that the view at the recommender systems changed, and as of now, recommender system, it's not just a tool for a user, it's mainly a tool for a business, and it's a key tool for a business to improve profit, to sell more, to the recommender system also changed, and we measure different metrics and optimize different goals. Made a great breakthrough, and a lot of researchers started to invest in recommender system area, trying different methods and etc. But there also were a certain degree of criticism for the Netflix price, because the approach used at Netflix efficiency offline was not perfect. They treat recommender system as an algorithm which predicts a rating, how high a user can rate an. Actually, what the people and the business need from recommender system, because actually what recommender system often need, a small bunch, only a few items from the very huge set of items, and it's very important how well of the list. While then you're working with a recommender system like a rating predictor, you miss this point, and you measure not only as good your recommender system is at the head of the list, but also in the tail and in the middle, and it's not often worth to invest there. At the time of Netflix price, method called learning to rank. It's a different view on a recommender system. We do not treat recommender as a rating prediction task. We treat it as a rank, and it's important how we rank the head of it. And it means that we need to use different metrics, and we also can use many different machine learning algorithms to produce this rating. And rank was the main. At some points, even learning to rank start experiencing problems. The main problem actually is that after a certain point, improvement in the algorithms, which you can see in offline evaluation, they stop converting to improvements in online tests. And it's a critical point for a business to perform online A/B tests, and we need some kind of filter to find which algorithm is better before start online testing. And there are a lot of reasons why it happened, and the main one was that the work in the recommender system influence users bias in the data. And when we try to train new recommender system on the biased data, we get a bias can perform worse when you put this model into online. There are also a lot of problems with modern recommender system. Put more traffic into popular items. They often cannot distinguish between situation when we are missing data about user item interaction, or if we are having a situation then item is not relevant for a user. And the classical learning to rank approach can do nothing about that, and it asked for new methods. And the new method which can solve many problems related to learning to rank approach is, of course, reinforcement learning. As Adrian told in the previous talk, it's a mainstream as of now for learning approach, because reinforcement learning provides us answers to many problems we've seen with learning to rank approach. Learning, we can treat all biases in the data related to the actions of the previous algorithms explicitly. We can explicitly balance algorithm between choosing the popular well-known items and trying new items we need to find information about. And there are also different approaches to validating recommender system offline. It's the simulation. And first, then I wrote the first paper about simulator used to test recommender system. I was kind of confused, why do we need that? And after a while, I realized that in the modern recommender system, we do not creating model. And in order to validate an algorithm which is learning online, we need different approach, not just but also in a simulation. And one of my colleagues later on in this session will tell more about the simulation. There are a lot of different approaches to reinforcement learning, but one of the most popular as of now in recommender system, it's different kinds of multi-armed bandits. And the technique was known long ago, and but it's effective, and it's for now evolving. But it's not the only one. Of course, there are a lot of different techniques related and based on the neural networks are also used in the recommender system. 3 years ago, a community called Reveal started at the recsys conference. The community was formed by the Microsoft, Criteo, and Netflix, and it was about using reinforcement learning and boost by the feedback loop in the recommender system training. And there are a lot of works we can rely now for applying reinforcement learning in recommender systems. And for example, there are two simulators created by Google and by Criteo, which simulate user behavior and allow you to test your algorithms, how well can it adapt to different and there are a lot of papers about using different reinforcement learning approaches. And one of my favorite one was published by Google a year ago. It proposes an algorithm for solving many interesting challenges in recommender system. Top K ranking task. It solves the problem of missing scores of previous algorithms, etc. So if you're interested in recommender systems and reinforcement learning, I would read this article. Of course, it's not the only one trend in the modern recommender system. That a lot of many interesting things going on. First of all, I would like to know learning criticism. The best paper of art of the recsys 2019 was given to the task perform wide validation of the recently published deep learning algorithms for recommend them are not reproducible, and even for those which can be reproduced, the performance was actually not really better comparing to classical algorithms. And it caused a lot of discussion, ongoing discussion, and even at recsys 2020, there was a continuation of this work evaluating even more deep learning techniques. One more interesting trend is multitask optimization. Often when you're creating a recommender system, you have multiple goals you want to optimize. You might want to optimize clicks, you might want to optimize retention, and you might want to minimize the complaints or negative actions of users. And it might be hard to put into single objective functions, and for that a common approach now is to create a multi-head, optimizing multiple goals at the same time. And I think the most important trend for now is a trend for more privacy and fairness in recommender system. As I've said in the beginning, the initial concerns 30 years ago was that the recommender system might influence the user privacy and user integrity, forcing user to do something it wouldn't do without recommender system. That's what we are seeing now, right now, and it's causing a lot of discussions. 2 years ago, the event of Cambridge Analytica, and the thing that Cambridge Analytica used data to create targeting, so basically solving the same recommender system task. Use it to promote political that was not companies were providing services for promoting and recommending targeting ads at social media, but at that time it was not about consumer behavior, it was about politics. Told that those interventions even changed the outcome of the president in 2016. And of course, it's faces a challenge. We need to provide some means for business to make recommendation, but we also want recommendations to be unbiased, and we don't want to influence user in a way it could be harmful. And to conclude, I would like to close the loop and to take a look at the keynote from the recent recsys 2020 related to this topic, and showing and asking a question. If the social media and the recommender system, recommender algorithms at the social media can influence the user, what can we do to address this challenge, to make recommender system safe and fair? And I think that's all from me. Thank you for listening, and join our Sberbank team for creating a future of recommender systems.
Thank you for your presentation. Thank you for your interesting thoughts. There is one question we have here. We have now some particular trends in safety of customer data. How do you think? How would these trends change how recommender systems would work in the upcoming years?
That's a very good question, and there are a lot of works in the academia trying to address this challenge. We have a method called differential privacy. We have different algorithms of federated learning, but the problem is that as of now, many of those approaches they can help to save the data, to make the data private without discovering the user data to the system, but they cause a huge performance degradation of a recommender system, or they require a lot of computational and communication resources to perform the task. I think that's one of the main challenges in the upcoming years, and I would like to see how it can be resolved. So we need not only the techniques to create a safer database with a more reliable security, we need different approach to the learning tasks, which allows us to hide the data even from the data scientist and the system, but still to allow system to make some conclusions and provide relevant recommendations.
Okay, thank you. And one more question. We have now many automation points in the recommendation process. We have AutoML that generates models. We have simple interfaces to enter campaign. What do you think would be the key role of human within the recommendation process in the upcoming years?
I think the main task for human is to set the right goals, and that's especially true with reinforcement learning. And to my not as simple as it could seem. And often, when launching a new algorithm with a certain goal, after achieving the goal with this algorithm, we realized that that was not the right goal. For example, you can try to optimize clicks, but after you get more clicks, you can see how the user retention decrease and etc. So it's very hard to set the proper goal, and that, to my mind, would be the main task for humans.